Hello everyone, welcome to the online course on digital logic design, and the topic of today's lecture is combinational circuits. We have already discussed that combinational circuits are those circuits in which the output at any instance of time is only dependent on the present set of input at that instance of time, which means that the output has no relation with the previous set of inputs or some previous set of output. And in the last video lecture we discussed one example of combinational logic circuit, and that was parity generator circuit. So we will continue our discussion, and here we will discuss another example, which is a BCD to 7 segment display decoder. BCD stands for binary coded decimal, and it is a kind of encoding scheme in which each of the decimal numbers from 0 to 9 is represented by its equivalent binary pattern, which is of 4 bits generally. So we have numbers from 0 up to 9, and each number is represented into its 4-bit binary. So 0 is represented as 0 0 0 0, 1 is represented as 0 0 0 1, 2 is represented as 0 0 1 0, and so on up to 9. 9 is represented as 1 0 0 1, and all numbers greater than 9, they are not represented. So binary coded decimal only counts from 0 to 9. Now our basic aim is to design a circuit, a digital circuit, which is a combinational circuit, which convert this binary coded decimal representation into another representation such that it is easily displayed on a 7-segment display. So 7-segment display is an electronic device which consists of 7 light emitting diodes that are arranged in a specific pattern, and this pattern is used to display hexadecimal numbers. We can see 7-segment display in a number of devices, for example wristwatches, clocks, etc. So 7-segment display is something like this. It has got 7 light emitting diodes. They are named as A, B, C, D, E, F. So it means at least 7 inputs are required to glow them, whereas the BCD is of 4 bits. So there must be an intermediate circuit which could convert the binary coded decimal into the 7-segment display compatible format. This is the basic aim of our today's lecture. 7-segment display are of 2 types. One is called as common cathode type. In this type of display, all cathodes of the 7 LEDs are connected together to the ground or negative, and LED display digits when some binary 1 or logic high signal is supplied to individual anode. The other type is called as common anode type, and in this type, in order to glow a certain 7-segment display digit, the individual LEDs are supplied with binary low or binary 0 logic signal. So we cannot directly connect a 7-segment display with the BCD source of information. First, our number must be changed to its BCD equivalent signal, and then BCD to 7-segment decoder converts that signals to the form which is fed to 7-segment display. So this BCD to 7-segment decoder has 4 input lines A, B, C, D, and 7 output lines A, B, C, D, E, F, and G, and each of the output line is connected to an individual LED of 7 segment display. So for example, when we have a binary 0 0 0 0 over here, then these lines are supplied with logic 1 in a particular manner, so that this display segment A is switched on, F is switched on, B is switched on, E is switched on, C is switched on, and D is switched on. So they together give an impression of a 0 digit to be displayed on the 7 segment display. And this is a truth table of BCD to 7 segment decoder. We have 4 input A, B, C, D, and together we have 9 combinations, because we want to display numbers from 0 to 9. So 0 0 0 0 up to 1 0 0 1. These are the input binary patterns that are compatible with the 7 segment display. And A, B, C, D, E, F, G are the individual signals of LEDs that are a part of display. So when 0 0 0 0 is supplied to the input of this display decoder, 1 1 1 1 1 1 up to F, all segments are 1, whereas G is 0. So this produces a 0 at the output. Similarly, for 0 0 0 1, the segment B, C are switched on, whereas all other segments are switched on. So B and C are switched on. So this produces 1 on the display, and so on. So we have total 9 input combination, and for each input combination there is a specific pattern of 7 segments that needs to be switched high. And using this K-map, using this truth table, we can come up with 7 boolean expression, 1 for A, B, C, D, E, F, and G, and each boolean expression is a boolean function of 4 variables. So let's look at them one by one. So here we have an example of how to switch on the LEDs. For example, if we want to display 9, so we will apply 1 to specific LEDs and 0 to some other LEDs. So if we look at the column for LED A, we have 1 in a number of rows, and for each row we will place a 1 in the corresponding box on the K-map. So after we have placed 1s over here, and as we know that for 4 bits the total number of possible input combination is 16. So from binary numbers 10 up to 16, this combination would be treated as don't care condition. So we can place X for them in the K-map, and this would help us in making the group of ones to further simplify the boolean expression. So for A we have simplified boolean expression equal to B complement D complement plus C plus BD plus A. Similarly for column B, the simplified expression is complement B plus complement C complement D plus CD. And in this way we can constitute the boolean expression for all the segments of the display, starting from A, B up to G. And then in the last step we can map these boolean expression onto logic gates, and we can design the logical diagram of a combinational circuit for BCD to 7 segment display decoder. So this concludes our example 2. We will see you in the next video for more examples.